Hello everybody and welcome to the video. In this video, I want to show you the fundamental difference between CAD and BIM. How are both the workflows different? And you better decide which is the most efficient one. So I will share my screen and let's take this forward from here. I hope you can see my screen. This is MacLeamy's curve. On the x-axis, we have different phases of the construction project, starting from preliminary design, detailed design, construction documentation, followed by construction and operations. Whereas y-axis represents effect, cost, or effort depending on the situation. There are 4 different curves and each curve has a different meaning, and we'll discuss them one by one. Starting from curve number 1, which is blue in color. This curve represents our ability to impact cost and performance. You can see that it is highest at the preliminary design phase. The ability to impact cost and performance is highest at preliminary design phase, and it is gradually coming down, and it is almost negligible at operational phase. I will elaborate this with a simple example for better understanding. Let's assume that we are working in a residential project and we are through with the initial phases of the project, and we are somewhere here in the construction phase. And the client comes up and he tells me, Mr. Dipankar, I have changed my mind, and I would love to include home automation in the project. At this point, we are somewhere here in the project in the construction phase, and implementing or considering this change would require rework at site. It may also require rework on design, coordination between architects and engineers. This may also require hiring a specialized vendor or a trade contractor. You know, the cost and effort involved in the later stage, or the change which is done at the later stage, would be significant. However, if this decision had been made during the earlier phase of the project, the impact on the cost and time would have been far less. Let's come to curve number 2 now. Curve number 2, which is red in color, this represents cost of design changes. So the cost of design changes is lowest at preliminary design phase, and it is gradually going upward, and it is highest at the operational phase. Let's continue with the same example to simplify it. The same residential project as an example. So let's assume that the project that we are working on is a 4-bedroom house, and let's assume we are at a construction documentation phase. Earlier we gave an example, we were at a construction phase. Now let's assume we are at a construction documentation phase, and the client comes up and he tells me, Mr. Dipankar, so this is a 4-bedroom house and I have changed my mind, and I would like to add one more bedroom, and let's make it a 5-bedroom house. We are already in a construction documentation phase, and the design is already locked. Building permits are approved by this time, tender drawings are issued, and the budgets are already set. Adding another bedroom disrupts all the preceding activities and ultimately increasing both time and cost, right? So this shows that design changes are far less expensive when made early in the project. Now let's discuss curve number 3, which is black in color. So this curve represents our traditional drafting centric workflow, which is also called as a CAD based workflow. So in this workflow, you can see that the effort is gradually increasing from preliminary design phase. And you can see that there's a bulge in the construction documentation phase, and again it is going down. You can see that in the CAD based workflow, the maximum effort is at the construction documentation phase. Our inference from curve 1 and 2 is that the ability to impact cost and performance is highest at the initial phases, and the cost of design change is lowest at the initial phases. Whereas if you look at CAD based workflow, the maximum effort is at construction documentation phase, and this does not look efficient as the inference drawn from curve 1 and 2. Is there anything that we can do here? So here comes the BIM workflow, which is curve number 4, which is green in color. Here in the BIM workflow, you can see that the effort is gradually increasing from preliminary design phase, and it is bulging out, or it is maximum in the detailed design phase, and it gradually comes down in the other phases of the project. So this looks very efficient as the inference drawn from curve 1 and 2. So this shows the fundamental difference between CAD and BIM. In CAD based workflow, we are putting in maximum efforts in the construction documentation phase, whereas in the BIM based workflow, we are putting maximum effort in the detailed design phase. So by front loading the effort in the detailed design phase, BIM enables us with more informed decision making. It reduces rework, and it saves time and cost. We can also say that BIM empowers us by putting in more effort at the detailed design phase of the project, and ultimately helping us in saving time and cost. Here we are not comparing between any CAD and BIM software, because my intent is to highlight the conceptual difference between CAD and BIM workflows rather than focusing on specific softwares. Hence, it also becomes crucial to revise your contracts, your payment terms, and delivery schedule when working on a BIM project. I really hope the examples were simple and relatable enough to help you break down the concepts. Please let me know your thoughts and ideas in the comment section below. I would love to hear from you. So with that, I would like to end the video. I thank you so much for your time. I'll see you in the next one.